Look at this, it's pretty amazing. This is the 2025 FRC game playing field, and it has 22 different April tags on it. What it means is no matter at which point in the field you are, no matter which way you're looking, you will still be looking at least one April tag. In other words, if you put four cameras on the robot, one on the front, one on the left, one on the right, one on the back, just from how many April tags these cameras will be seeing, it's possible to estimate where the robot is precisely, just by looking at all the tags around you. Let's see what it will take. Super simple geometry, very simple, much easier than the last years. Let's see if we can make it happen. Let's see if we can add such localizer to our robot today. So if we go back to our main Swerve template with documentation, what are the things we can add to the robot? We can add an arm, a camera, an intake, and so on, and we can also add a localizer by reusing the photon vision cameras. Good news is in the previous video we just installed two photon vision cameras, so now we can join them into a localizer. Click. So here is what we need to do. Um, First of all, in our requirements.txt, we will need to install additional dependencies. Let's do that. I go to requirements.txt and I'm going to put those additional dependencies at the end. PhotonLibPy and RobotPy April tag. Second, what else do we need to do? In PyProject.toml, we also need to change the requires line to require these things, at least those things. So I go to PyProject.toml and I change this requires line to require PhotonLibPy and RobotPy April tag. Okay. Now, in order to make sense of the field, we need to have the map of the field. So just for today, it's actually easier to use the last year's map of the field, the crescendo. It's provided here, but you can just download them from the first website also. So I'm gonna copy the field map and I'm gonna put it into a file called 2024 crescendo.json. Okay, let's add the map of the field. New file 2024 crescendo.json. Map of the field. It pretty much tells you at which tag is located at which location. For example, tag 16 is located at X of this and Y of this and Z of this, and this is how it is rotated. Okay, map of the field is added. Finally, we need to add a new subsystem, Localizer. Here's the code for an example localizer, but please feel free to change it. Go to subsystems and we're gonna add a localizer. Localizer dot add. This is going to be our localizer subsystem. And finally, we need to add a localizer to the robot subsystems. So we must go to robotcontainer.py and we should first add localizer. So let's go to robotcontainer.py and wherever we add all the subsystems, maybe somewhere here, we're going to add the localizer. We're going to use the 2024 April tag field layout. Now, this localizer is not aware which cameras it can use. So what we need to do is we need to add two cameras on that robot. We have a front camera and we have a left camera. So that should be it, kind of. Left is considered the plus 90 degrees, right would be minus 90. Trouble is, those cameras on this robot are not exactly in the middle of the robot. They are at the front of the robot, both. So what we need to do is we need to say position from robot center is X. They're 30 centimeters, 0.3 meters to the front of the robot. But otherwise they're in the center of the robot, so X of 3, they're 0.3 meters forward from the center of the robot. Both. So we need to clarify this, otherwise we're gonna have 30 centimeter error in our position. This is it. The localizer was added. The cameras were added into the localizer. Let's see if it works. We will need to deploy it. We need to connect to the robot and deploy. Okay, now let's test our localizer. What I did is I am taking us back to year 2014 to the crescendo field. On this field, we had tag number 4 in here and tag number 1 in here. In other words, this whole wall of the field only had 2 tags on it, tag number 4 and tag number 1. So here in my garage, I have a wall. I have put a tag number 4 in the middle of the wall and tag number 1 all the way at the end of the wall. Finally, I have put a robot. Let's go to the Photon Vision page of the robot. In this case, it's just photonvision.local. I did not rename this into front left, front right. I just kept it photonvision.local. And apparently the front camera is seeing 2 tags. Tag number 4 in here and tag number 1 in there. As you can see in the results, tag number 1 is 20 degrees to the right of the center. Yeah, it's kind of on the right. And tag number 4 is minus 25 degrees on the left of the center. Okay, so if my geometry serves me right, if I'm seeing tag number 4 kind of 20 degrees, 25 degrees on my left, like this, and tag number 1, 20 degrees on my right, like this, then I kind of have to be somewhere here. That's the only way. I have to be here in order to be able to see this tag 20 degrees on my right and this tag 20 degrees on my left. But the play pretend robot position in this field is all the way there. And you can see localizer is off. Let's turn the localizer to the demo mode, in which it shows what it would have done, but it actually doesn't do it. Switching localizer to the demo mode. So apparently it notices 2 tags, tag number 4 and tag number 1. And the line going from robot to the tag is just robot to tag, but the line going back from the tag is where localizer wants to place the robot based on the angles. And look at this, localizer wants to place the robot somewhere where this line and this line intersects, because these are the true visible angles to the tag. Okay, let's enable this localizer, switch it from demo to on, and see where it places the robot. It's moving robot all the way to this point. Now, everything makes sense. Indeed, tag number 4 is 25 degrees to the right, and tag number 1 is 20 degrees to the right. Now let's do something. I'm going to switch to teleoperated mode, and I'm going to move the robot. I'm going to turn the localizer off, and I'm going to move the robot to the side. Look what happens on the screen. So now the robot has moved to this location and somehow its position has reset, which I've yet to debug. But let's see where it will be placed right now if we enable the localizer again. Localizer on. It's only seeing one tag, so it's only trying to make sense of one tag. Because it doesn't see the tag that's further away. Okay, now the tag that's further away is more visible, and Localizer is trying to place the robot kind of in a way that makes sense with respect to both tags. Here. Okay, what happens if I move the robot with the Localizer on? So it still guessed the position correctly, even though the other tag was only visible some of the time. Now I'm going to move it towards the tag in question and see how Localizer is updating the position. Again, it's not detecting all the tags because one of the tags is not in our view right now, so we can rotate the robot a little. Now both tags are in the view, and hey, the position was maintained correctly. Now let's make it so that one of the tags is shown on one camera and the other tag is shown on the other camera. Will it still guess things correctly? Robot is uh, turning in such a way that one camera sees one tag and the other camera sees the other. Okay, the other camera doesn't see anything. Okay, now one camera sees this tag, the other camera kind of sees that tag sometimes. Let's change the resolution. The reason it doesn't see that tag very well is because the resolution is bad. Now the resolution is better and it's seeing that tag constantly, and the front camera is seeing the front tag also constantly. The localizer is showing us that, yeah, I'm looking at both tags, and this is what my position should be, based on where I'm seeing them. Robot is turning. Sometimes it can only see one tag, sometimes the other, but localizer keeps its position updated. Let me show you something cool that you can only do when you have a working localizer. Say, for example, we want to go to the point that's here. Uh, Here on this line. It's kind of in between this tag and that tag. The coordinates of that point are, uh, well, we can call it midpoint. Get to midpoint. The coordinates of those points are x is, I think, 15, and y equals 2.75. Or maybe even this point. I forgot what the coordinates are, I'll be honest with you. But okay, let's stick with this point, 15, 2.75. You can only get to there if you really, really understand where you are given the tags. So we're going to say return go to point command, and we need to give it x, y, self dot drivetrain speed equals 0.2. And of course, we want to make it an autonomous command, so we can say we can add it to the list of chosen autos and configure autos function. Self dot chosen auto add option go to midpoint. Self get to midpoint. That's the function name, right? So let's deploy this code to the robot. Something is not quite right. Oh, I forgot a command here. Yes. The code is deployed to the robot. And again, I'm going to move the robot using teleop. Okay, so it sees enough tags right now. I'm going to switch it to autonomous, but it really doesn't understand where it is on the field. I'm going to say my chosen auto is go to midpoint. I really want the robot to go to this location. And let's turn that localizer on and see what we get. Localizer puts the robot into this position because it only sees two tags. And from this position, it's supposed to go to the midpoint between those two tags. Let's see how it does that. Turning the auto on. There we go. It has ended at the position between two tags. And let me show you where it actually is. Yes, indeed, it ended up in between those two tags. At this midpoint. Now imagine a situation in which we want the robot to just use the tags that it sees around itself to go to some point on the field, for example, right under the stage. So we are now in this situation. I want the robot to go to this point. So I wrote a little function here, go to stage. I know the coordinates is x is 11.5 and y is 4.2. These are the coordinates of this point under the stage. And I bound it to an auto called go to midpoint. So go to stage function will be called to create a command for this. Uh, what I can do is I can go to Elastic and I can say, hey, I want to use this command and let's see if it can work. As you can see, the camera is seeing both tags. So if I turn the localizer on, it will place the robot in the position on the field that's consistent with those tags. Okay, we want the robot to go under the stage and we want to use the visual navigation for it. We have the auto that does exactly this. It's here, go to, I'm sorry, it's here, go to stage. It takes the robot to the coordinates of the stage, 11.5, 4.2. It's this point on the field. Can it do it with visual navigation? Let's run it. Enable auto. Perfect. It reached the stage, even though it was not always seeing the tags.